Hello all. Today we will explore engineering mechanics basic concept. First we will see what is particle, then thereafter we will explore body, difference between particle and body, rigid bodies, deformable bodies, one dimensional, two dimensional, three dimensional bodies and mass, weight. So let's see what is particle. Particle is infinitely small part of a body. This word is important here in this bullet point. Infinitely small part of a body. Let us consider one body. Let us consider this as a body and see here. This is one point in that body. So that is particle. This point is particle. It should be infinitely small. So this body is made up of infinite particles and this one is particle. Second bullet point is particle is a body that possesses mass. So this body possesses mass. This body have its own mass and weight. Mass is nothing but the quantity of matter contained in a body. So the particle is a body that possesses mass but has dimensions so small. One may assume that it may occupy a single point in the space. If this is x direction, this is y direction, and this is z direction. This is space, and this is single point in that space. So this is particle. Particle has no dimensions and shape. It has no dimension, shape. The concept of, see this bullet point, fourth bullet point, the concept of particle is similar to that of a point in geometry. I told you already, cube shape, inside it, particle. Point has location but no dimension. See point, this has location but no dimension. Why no dimension? Because of it is infinitely small. A particle is a body whose size does not influence its response to the force acting on it. If this is particle and force acting on this body, the particle is a body whose size does not influence its response to the force acting on it. In other words, the body may be modified as a point of concentrated mass and the rotational motion of a body can be ignored. Why rotational motion of a body is ignored? Because see, these two forces, either one force acting on this body, and is this body rotate with the help of this force? No, this body does not rotate. So that is meaning of these bullet points. And size of this particle does not influence. A particle is a body whose size does not influence its response to the forces acting on it. Next concept is body. Read this bullet point, first bullet point, we will read this. A body is defined as a matter which is limited in all directions. If this is some shape, so this is nothing but the body. And this body is made up of infinite particles, matter, which is limited in all directions. What is matter? Matter meaning this body has mass and this body has weight. Second bullet point is a body is composed of infinite number of particles and it has definite shape and size. So what is difference between particle and body? Particle has dimensions. Particle doesn't have dimension. That means dimensions are negligible here in particle, and in body dimensions are considered. Second point is, for particle it undergoes translation only. Particle doesn't have rotation when force acts on it. Particle only has translation. So what is translation? See, if this is particle and force acting on it, so when force acting on it at t is equal to, so let it be that time. So if force acting on this particle, so this particle will be move towards or throw towards here in this. So this is translation between here to here. That point translate from here to here. So that is meaning of that. Particle has translation but doesn't have rotation when force acts on it. Body undergoes translation and rotation also. This is body. When force act transfers to this body and we will take movement here, then movement acts on this body. If this is P and this is E, then movement at this point is P into E. So that body, when force acting on body, so body has translation always and rotation always. So if there will be no supports here on body, then it will be translate to up to, it will translate up to here. So that is meaning of that second serial number, differentiate between particle and body. Third is, particle has no size and shape, but body has size and shape. Particle occupies point in a space and body occupies volume in a space. See, that is very important. Point and space, very important differentiate. Body occupies volume and particle occupies point. Now we will move towards rigid body concept. First, read this definition. A rigid body is a body in which the distance between the particles constituting the body does not change under the action of applied forces. So let us consider this as a body made up of several particles, but we will take interest in this particle and this particle in, and if force acts on this body, so due to that forces this particle will not change its position. This particle will remain as it is in this position. So this is meaning of this rigid body. A rigid body is the body in which the distance between the particles constituting the body does not change under the action of forces. This D should not be changed when any either force acting on this body. Generally, that rigid body is an idealized concept. There is no body or material in the universe 100% rigid. All materials used in engineering, steel, concrete, etc., do suffer some deformation, but too small to change the overall dimension of the body. Rigid body is again an idealized concept. So, what is deformation? See, here we saw that deformation. So, in our fifth point, deformable bodies. Deformable body is the body in which there is a considerable change in the distance between the particles, constituting the body under the action of forces. So that rigid body and deformation body totally reverse concept. Deformation body, consider this as a beam, and if compressive forces acts on this beam, maybe that compressive force is too high. Due to compressive force, this beam compressed, it changed its shape up to here. The distance between particle also change. This d is decreases here. Deformable body meaning is that due to that compressible forces, this body change its shape and these particles also changes. Particle distance between particles also changes. Here it is compressive force, that means distance between particle decreases. If it is like this, body is like this, and tensile force, so body shape will be changed like this, and there the distance between particle increases, either decreases, but it should change its shape. Strain change in length upon original length, so deformable body. Because of this, the overall dimensions of the body are affected, or it has significant effect on the motion or equilibrium of the body. So how it is affected on equilibrium of the body? Maybe this body is in equilibrium initially, but after applied forces it will not be in equilibrium. Because of this, the overall dimensions of the body are affected and it has significant effect on the motion or equilibrium of the body. Because of this, the stress develop inside it. Because of that compressive forces, that tensile forces, stress develop inside it. So meaning of that sentence, equilibrium, motion. Next we will see one dimensional bodies. So a body is said to be one dimensional if any one of its dimensions out of three is considerably large as compared to other two dimensions. Example of that is thin metal rods, wires, rope, cables, etc. This is x direction, y direction, z direction, and this is one rope. Length of that rope is too large as compared to width and thickness. So this is one dimensional body. A body is said to be one dimensional if any one of its dimensions out of three is considerably large compared to other two dimensions. Here other two dimensions are width and thickness. So here length is considerably very large as compared to width and thickness. That means this is one dimensional body. Two dimensional body. A body undergoes change considerably in two directions, that means along length and breadth. Examples are thin metal sheets, plates, lamina. A body is said to be two-dimensional if any one dimension is considerably small as compared to other two dimensions. Example, consider this as a steel plate. See, this two dimension, this width and length are too large compared to its thickness. This is thickness. So that's why it is two-dimensional body. A body undergoes change considerably in two directions. That means along length and breadth. One dimension is small as compared to other two dimensions. Comparatively small, considerably small. Yes. Third is three-dimensional bodies. A body is said to be 3D if all three dimensions are considerable. The effects are considered in all three directions along length, breadth, and depth or height under the action of applied forces. Example, machines, buildings. So example, this is 3D body. length, it has length also, width also, and thickness also, and all are considerable. Next, we will move towards mass. Mass is the quantity of matter contained in a body. It is measured in kg. For a given body, it is always constant. It will not change from place to place. Every body has mass and it is measured in kg. And it is quantity of matter. And what is matter? This matter word. Meaning of matter word is any substance that has mass and takes up space having volume. Any substance that has mass and takes up space having volume. And we already saw that mass and matter. Matter is anything that has mass and takes up space. It will be solid, liquid, gas, plasma. Now weight. All bodies in the proximity of Earth's surface are subjected to gravitational force. Proximity. Meaning of that proximity word is the state of being near to something, near to Earth. All bodies near to Earth's surface are subjected to gravitational force exerted by the Earth on the body, known as weight of the body, and it is measured in Newton. Formula for that formula for weight is equal to mass into acceleration due to gravity. We had saw mass and acceleration due to gravity also. Acceleration is nothing but the rate of change of velocity divided by rate of change of time. So acceleration due to gravity. Why acceleration due to gravity? W is nothing but the weight in Newton, mass is in kg, and g acceleration due to gravity. Value of g 9.81 and acceleration unit meter per second square. In this video lecture, we saw concept particle, infinitely small part of a body which has directions. A body is defined as a matter which is limited in all directions. We saw differentiate between particle and body, rigid bodies, deformable bodies, one-dimensional, two-dimensional, three-dimensional bodies, mass and weight. So thank you very much.